Hi, welcome back to the Stack Mastery class where we are solving problems that needs stack as a key data structure. So stack isn't just for complex problems, it's also great for simply string manipulation. So here's the straightforward question in which we need to reverse prefix of a word. So if we have a word like this, now we need to first find that where the D is present. So from the 0th position to that point, we need to reverse this. So we will be reversing A, B, C, D. Why? Because D is present over here as a first occurrence. So after reversing, we will be getting the result as D, C, B, A. Okay. And everything will be normal. E, F, D. Okay. So we need to return this string in which I have reversed only this part. Now let's take one more string. Now over here, we can see that Z is present over here. So we need to reverse till this point. And after reversing, we will be getting Z, X, Y, X, X, E. So here we can see that I have reversed this part, X, Y, X, Z. Okay. Now let me take one more string. Over here, we can see that I want to reverse the prefix, right? But this Z is not present inside this string. So if the character is not present inside the string, then we need to return as it is, which is A, B, C, D, right? So this is the question. I believe you got it. Now here we will be solving this using the stack. Although there are many methods to solve this problem, but here since we are in the stack series, so I will be telling you that how we can solve this using the stack approach. Now see, here we can see that we need to reverse this part, right? So I will be storing or I will be pushing each character one by one into the stack. And since stack follows the last in first out, so while popping, I will be getting D first, then C, then B, then A. Let me take one example and I'll show you how. So, and the character is D. So we need to reverse this part. Right now, here's the stack. Now, first we will insert or push A, then B, then C, and D. Now, when I encountered D, I got to know that it is matching with the character, so I'll stop it. Okay. Now I'll create one more string in which I will append this popping element first. Okay. So I'll pop D and I'll put it over here. So let's say this is an answer. And then I'll pop C and I'll append it over here. Then I'll pop B and I'll append it over here. And then I'll pop A and append it over here. Now, after this, my pointer was over here, right? Now what I'll do, I'll simply move forward over here and I'll simply append all the characters till the end. And here you can see that I got the desired string. So I believe you got it. Now see guys, first I'll check that whether it's D present inside this word or not. If it is not present, then I'll not do anything. I'll simply return that string only. Okay. So the pseudocode. Since we are returning a string, so string, the data type of the output, then the function name as reverse prefix. Okay, so this is the LeetCode problem by the number 2000. So you can check it, and over there function name is reverse prefix, in which word is given and a character ch. Okay, now let me create this stack first. Now I'll create a string builder in which this string I will be passing. So the name is SB new string builder. Now first I'll check whether the character is present inside the word or not. So int idx is equals to, there is a function in Java in which it will give me at which index the character is present inside that word. So word dot index of, okay, over here I need to pass character. Now see, if the character is not present inside the word, then this function will give me -1, stating that the character is not present. So I'll have a if case over here, so that if index is equals to -1, then I'll need to simply return the word only. So return word. I don't need to reverse anything. But if this is not the case, then I need to push from 0 to index into the stack. So I equals to 0 and it will be gone till less than equals to itx. Now stack dot push word dot caret I. So this function will extract each character one by one and it will push into the stack. Now after pushing, I need to pop it and I need to store it, or I need to append it in this SB. Okay, so I'll have a while in which I need to pop it until the stack is empty. So stack dot is empty. And here I need to have a not. Okay, so this will be keep running until and unless stack is not empty. Now SB dot append stack dot pop. So it will pop one by one and it will store, or it will be append into the SB. Now after this, I need to append the remaining characters into that SB. So for int I equals to idx plus 1 to n, SB dot append word dot character at I. And that's it, guys. We are done for this. Now I need to return SB. Now see, in the question they are expecting the string, but here the SB is a string builder, so I need to convert it. And to convert it, I just need to write toString. So this function will convert the string builder into the string. And we are done. Now talking about the space complexity. Okay, since we have taken the help of the stack, so obviously the space complexity will be order of n. And talking about the time complexity, it is order of n only. Okay, so I believe you got it. If you didn't, I would be advising you to please dry run it by yourself as well by taking any of these examples. Okay. Now, if this lecture helped you understand the concept better, make sure to like the video, share it with others who are learning, and don't forget to subscribe for more easy DSA explanation. I thank you so much for watching till the end. I'll see you in the next lecture. Till then, keep practicing.